Hi, welcome to EROTECH Solutions. Now we are trying to discuss on interrupts from the microcontroller. In previous sessions we discussed about the IOs and timers and counters from microcontroller, and moving on to the next block, interrupts. The simple meaning interrupt is it is a disturbance. So in our general meaning you will feel that interrupt is a disturbance, but how the microcontroller is making it as a feature of device. Okay, so like whenever you are trying to solve a problem, before proceeding interrupts, so you need to know about the polling method. Like if you develop any logic for microcontrollers, if you have multiple conditions in the application, so in our case we will follow this regular if conditions. Like the first condition is true, then the compiler will take care of first condition statements. After completion of first condition statements, then it is going to check second. If it is false, then it will go for third. If it is false, then it will go for fourth. Now I'll tell one simple example. Like one doctor is monitoring 10 patients. He has a rounds for every 1 hour, and he is checking every patient at least 10 minutes in the 1 hour session, and he is checking first person, and after 10 minutes he will go to second, and after that he will go for third. Like he's keep on checking first, second, 1 to 10 persons. And in some case you have some emergency with the 8th person or 7th person. If the doctor is checking with first person, then if he is going a regular method, like is whatever his rounds for 1 to 10 is going in a sequence order, the 8th person have so much of damage. Okay, so whatever the regular process he is doing, he needs to break that, and he has to go for emergency for 8th person. And after completion of that 8th person case, then he can return for his regular process from 1 to 10. So this is the same thing you are applying here in our microcontroller statement execution or functions execution or modules execution. So anyway, your controllers follows either top to bottom or bottom to top program execution procedure. And once you started with first condition, after checking first condition only, the compiler moves to second, and after second, then only it will go for third. It is a step-by-step process. Your compiler no have choice or no have priority. It cannot go 9th condition or 10th condition without checking the remaining or previous conditions. In such cases, your application needs some emergency, or you want to break that regular procedure, then you want to go for some emergency, you need to use this interrupts block from the microcontroller. So the main motto of interrupt is very clear. It is going to stop the main program execution whenever interrupts come to the microcontroller. Then it stops that main program execution and divert it for ISR, which means interrupt service routine. And this interrupt service routine is high priority task from the application. Okay, so whenever you have a high priority application in your program, then you need to put up that high priority part in your ISR. So if you want to execute that, if you need to provide interrupt, and after completion of this ISR, then the compiler as usual go for where it stops the main program. You can find this thing in ATM execution or ATM operation. So before swiping your card, your ATM machine keep on showing advertisements, but once you swipe the card, it immediately stops that advertisements and do your high priority task transaction, and again after transaction it will go for as usual activity, some ads or whatever the bank methods, so all these which is going to display on ATM machines. So if you want to make that high priority task with electronic device, so you should be very you have to watch out this interrupt block from any microcontroller. And again, interrupts are coming in the next level controllers like maskable interrupts, non-maskable interrupts. Okay, so this is the next level of interrupts. But whereas in basic controllers, interrupts are categorized into two types. One is hardware interrupts, and the second category is software interrupts. So what is the meaning of hardware interrupts from microcontrollers? So hardware interrupt means you need to provide external pulse, like whatever the high to low pulse you need to provide from outside source, like through sensor or through button, whatever you want, you need to provide from outside source. So those interrupts comes under hardware category. And what about software interrupts in microcontrollers? Software interrupts are generated through flag bits. So whatever the process, suppose if you take timers as example, if the timer completes one rotation, automatically timer flag is becoming 1. So this is not done by hardware, this automatically becomes 1. So whenever you want to stop that main program execution for flag bit logic, then if you need to activate the software interrupts. If flag bit is becoming 1, then automatically microcontroller stops main program execution and diverted for ISR. So this is the difference between software interrupt and hardware interrupt. So 8051 supports 6 interrupt resources for us. Out of 6, 3 are hardware and 3 are software. And 3 hardware interrupts names are reset. Reset is not a programmable interrupt, but why they consider as an interrupt for microcontroller? It is stopping main program execution. Whatever the pulse which will break my main program execution, it comes under interrupt. So reset is not programmable, but only for name count purpose they took this reset is a hardware interrupt. And the other 2 hardware interrupts names are INT0 and INT1. So these 2 pins are available from microcontroller across pin number 13 and pin number 12 and pin number 13. So you need to provide external high to low pulse across pin number 12. And your hardware interrupt which is generated for microcontroller. And whereas interrupt 1 you need to provide across pin number 13. So these 2 pins are 2 hardware interrupts for the microcontroller. And what about 3 software interrupts? So 3 software interrupts names are TF0, which is timer 0 interrupt, and timer 1 interrupt, and serial communication interrupt, which is serial interrupt. So you need to know about when microcontroller stops main program for hardware interrupts and when microcontroller stops main program execution for software interrupts, which is very clear. By providing external pulse, your hardware interrupt which is generated for microcontroller, which means internally it stops main program and diverted for ISR. Coming to software interrupts, timer 0, timer 1 and serial interrupt. So these are generated according to the flags. Whenever you are using timer 0 in application, if you TF0 becomes 1, then microcontroller stops main program and diverted for ISR. Whereas timer 1 interrupt means whenever TF1 becomes 1, then microcontroller stops main program and diverted for ISR. Whereas serial interrupt, this is depends on TI or RI bits from SCON register. So these 2 bits, whenever 1 byte data transmission is successful, then TI becomes 1. Whenever 1 byte data is received from external device to controller, your RI becomes 1. So based on these 2 bits logics, you can stop main program and you can execute your ISR. So that is the simple difference between software interrupts and hardware interrupts you need to understand. So these interrupts, how can you generate? So whenever you are trying to use these interrupts for applications, so again you have to aware of some standard SFR registers related to interrupts, which are IE, IP and TCON. So these 3 registers you need to understand. So these 3 registers you will see in the next session. Thanks for watching.